Welcome back, students, to another part of our discussions on lesson 2 Is Matter Around Us Pure from the syllabus of chemistry in class 9. In the previous class, we had completed up till the topic of solutions and suspensions. Today, we will introduce a new topic, that is colloids. I would quickly discuss the answer for the question that I had given you as an assignment in the previous session, that was how to distinguish between solutions and suspensions. For that, you can refer to the picture that is right now coming on your screen. This picture actually gives a clear distinction between solution and suspension. Obviously, both belong to two different categories of mixtures. Solution is homogeneous because the particles are distributed uniformly inside a solution, whereas a suspension is heterogeneous in nature. It lacks homogeneity. If we want to separate out the components of solution and suspensions, in case of solution, using the simple technique of filtration, no residue particles are left on the filter paper. But in case of suspension, if filtration technique is employed for separating out the particles, then the insoluble solids are left behind on the filter paper. The last point of distinction was actually what I was showing through this picture. You can see in the picture that the particles of suspension have settled down, or rather they have precipitated. This means it lacks stability. Whereas in case of solution, the particles remain suspended inside the solution. They do not separate out. That is, solution is stable. So when a solution is left to stand, the solute does not separate from the solvent. But in case of suspension, when the suspension is left to stand, the insoluble solids settle to the bottom of the container. Now the question, what is a colloidal solution? Before I give you the definition, you can see the definition of colloid coming right now on your screen, but what I want to show is the distinction in the particle size. You know about a true solution, you know about a suspension, but check the size of the particles in a colloidal solution. For true solution, the size is less than 1 nanometer, that is 10 to the power minus 9 meter. For suspension, the size is greater than 100 nanometer. But for colloids, the size is between 1 to 100 nanometer. This means it lies intermediate between a suspension and a true solution. So how to define a colloid? Rather, what is a colloid? A homogeneous non-crystalline substance consisting of large molecules of or ultra-microscopic particles of one substance dispersed through a second substance. Repeat, a homogeneous non-crystalline substance consisting of large molecules or ultra-microscopic particles of one substance dispersed through a second substance. Colloids include gels, salts, and emulsions. The particles do not settle and cannot be separated out by ordinary filtering or centrifuging like those in a suspension. Some examples include whipped cream, mayonnaise, milk, butter, gelatin, jelly, muddy water, plaster, colored glass, and paper. Every colloid consists of two parts, colloidal particles and the dispersing medium. The dispersing medium is the substance in which the colloidal particles are distributed. Let us understand more about colloids. Now for that, let's begin with the shape of the colloid. You can see that colloids might exist in different shapes. The word colloid has been derived from the Greek word kolla, which means glue. Thus, colloidal particles are glue-like substances. These particles pass through a filter paper but not through a semi-permeable membrane. Now, you know what is a semi-permeable membrane, about which you have studied in biology. You know that this is a membrane which partially allows the particles to penetrate through them. So colloid particles cannot penetrate through a semi-permeable membrane. These particles can be made to settle by the process of centrifugation. Now, detailed study of the process of centrifugation will be undertaken when we come to study of different techniques of separation of the components of mixture. So about which in this very lesson we will be studying. But right now you should only know that the particles of colloid can be settled by the process of centrifugation. Let us learn more about colloids. Colloid is a phase-separated mixture in which one substance of microscopically dispersed insoluble or soluble particles is suspended throughout another substance. Sometimes the dispersed substance alone is called the colloid. The term colloidal suspension refers unambiguously to the overall mixture. Unlike a solution whose solute and solvent constitute only one phase, a colloid has a dispersed phase, that is the suspended particles, and a continuous phase, the medium of suspension, that arise by phase separation. Typically, colloids do not completely settle or take a long time to settle completely into two separated layers. So you can see that the colloidal system consists of two phases, a dispersed phase, that is the discontinuous phase, and the dispersion medium, that is the continuous phase, as it is quite clear through this picture. The dispersed phase particles have a diameter between approximately 1 and 1000 nanometer. Such particles are normally easily visible in an optical microscope, although at the smaller size range, an ultra microscope or an electron microscope may be required. Homogeneous mixtures with a dispersed phase in this size range may be called colloidal aerosols, colloidal emulsions, colloidal foams, colloidal dispersions, or hydrosols. Talking about size and shape of colloids, let me tell you that the size of the colloids sometimes affect the property or its field of application. Like for example, you will be surprised to know that the size and shape of colloids results in platinum as an effective catalyst only it is found in colloidal form due to large surface area which adsorb reactant on their surface. Or say, talking about the color of a colloidal dispersion, that is also very much related to the size of the particles. For example, red gold sol takes a blue color when the particles increase in size. Size and shape of the colloids are very much important in also the exhibited properties. The more extended the particle, the greater its specific surface, the greater is the attractive force between the particles of the dispersed phase and the dispersion medium. Flow, sedimentation, and osmotic pressure of the colloidal system are also affected by the shape of colloidal particles. I would like to show you some pictures that can be considered as examples of colloidal systems from our daily life. You can see solid aerosol. In case of liquid droplets, you are having gel, emulsion. Liquid aerosol. In gas, it is having solid foam or say simply a foam. Common examples include foam, milk, fog, detergents. So these are general colloids. Talking about properties of colloids, we can classify the properties of colloids into two groups: kinetic properties and optical properties of colloids. Let me give you a brief understanding about the observed properties of colloids. As we all know that colloid is very much a heterogeneous mixture. So the size of particles of a colloid is too small to be individually seen by naked eyes. The zigzag movement of colloidal particles continuously and randomly take place, which is sometimes referred to as the Brownian motion. This Brownian motion arises due to the uneven distribution of the collisions between colloid particle and the solvent molecules. Brownian movement was more rapid for smaller particles. It decreases with increase in the viscosity of the medium. Coming to the next category of properties of colloids, that is the optical properties of colloids, a very important field of study becomes the Faraday-Tyndall effect. Now this is a very common observation. You all have already seen Tyndall effect. Where have you seen it? Tyndall effect can be observed when sunlight passes through the canopy of a dense forest. In the forest, mist contains tiny droplets of water which act as particles of colloid dispersed in air. If suppose you project a beam of light through milk, you will find that fine beam of light enters into the container containing milk. The path of light becomes visible. You might have also observed that when a fine beam of light enters a room through a small hole, then due to the scattering of light by the particles of dust and smoke in the air, the path of light becomes visible. So this is Tyndall effect, which has been named after the name of the scientist who discovered this effect. So the Tyndall effect, also known as Tyndall scattering, is light scattering by particles in a colloid or particles in a fine suspension. Now it is quite similar to Rayleigh scattering, about which a little bit of information will be provided when you study about scattering phenomena in class 10 physics. It is similar to Rayleigh scattering in that the intensity of the scattered light depends on the fourth power of the frequency. So blue light is scattered much more strongly than red light. An example in everyday life is the blue color sometimes seen in the smoke emitted by motorcycles, in particular two-stroke machines where the burnt engine oil provides the particles. Now I would like to discuss about a topic that is not included in the syllabus of class 9 chemistry, but I would still like to include this in the study of colloids, because you should have a little bit more information whenever you are studying about any topic. So types of colloids. There are two types of colloids, lyophobic and lyophilic. Now these are new terms, and whenever a new term is introduced, it is very important to understand the meaning. Phobic means repelling or hating. Phobia generally refers to some kind of fear, but in this sense it is referred to as repelling or hating. So lyophobic means solvent repelling or solvent hating. The particles resist solvation and dispersion in the solvent. The concentration of particle is usually relatively low and they are less viscid. These colloids are easily precipitated on the addition of small amount of electrolytes or by heating or by shaking. Less stable as the particles surrounded only with a layer of positive or negative charge, and once precipitated it is not easy to reconstitute the salt by simple mixing with the dispersion medium. So examples include salts of metal and their insoluble compounds like sulfides and oxides, for example gold in water. Similarly, coming to the next group, lyophilic, solvent attracting. The particles in a lyophilic system have a great affinity for the solvent. If water is the dispersing medium, it is often known as a hydrosol or hydrophilic. They are readily solvated, combined chemically or physically with the solvent and dispersed even at high concentrations. I will not go into very much detail of these two topics as these will be covered up in higher classes when you deal with the topic of colloids in chemistry, but for the time being you should have a brief introduction regarding the different types of colloids. Next I will come to the basic examples, like the common example of colloids. Depending upon the dispersed phase and the dispersing medium, a common name is given, and you should try and remember a couple of examples. Like for example, if the dispersed phase is solid and the dispersing medium is also solid, it is called a solid sol, and the examples will include colored gemstone, colored glasses, milky glass, solid dispersed phase, and a liquid dispersion medium. It is called a sol. So that includes paints, muddy water, gold salt, starch sol, arsenous, sulfide sol. Solid dispersed phase, and the gas is a dispersing medium. That is called an aerosol. So that includes smoke, automobile exhausts, dust. Liquid in solid, that is called gel. So obviously jellies. Then liquid in liquid, that is called an emulsion. So that will include milk, face cream, cod liver oil. Liquid in gas, that is called a liquid aerosol, that includes fog, clouds, mist. Gas in solid, that is a solid foam, that will include foam, rubber, sponge, pumice. Lastly, gas in liquid, that is also called foam, that will include froth and whipped cream. So these are common examples of colloids. Depending upon the dispersed phase and the dispersing medium, we can assign a specific name, and there are a couple of examples, couple of things that we commonly found, that are found around us. They can be placed in this group. Now I would like to mention at this point that you should try and remember this particular set of data, as quite often you get some questions related to it. Applications, again something out of the scope of your syllabus, but still I have included it. Applications of colloids: rubber plating, sewage disposal, smoke screen, purification of water, cleaning action of soap in medicine, formation of delta, photography, artificial rain. So how colloids are finding application in different fields? That is a very important field of study, and as I was telling you that this is not prescribed in the syllabus for class 9, but you will be studying in detail about the different applications of colloids in your senior section. So I'd just like to include a couple of these. Like in the field of food and medicines, colloids have great application in food industry and foodstuffs. Many of the food particles which we eat are of colloidal nature. Milk products like cheese, cream. In water purification, we know that one of the very popular methods used for water purification is the addition of electrolytes like potash and alum. Commonly used things. Alum, about which we have studied in the field of loading. We will be studying about that process further in this chapter. Sewage disposal. The sewage water contains impurities like mud and dirt of colloidal size, which are dispersed in water. Just like any other colloidal system, the colloidal particles of sewage are also charged particles. These charged particles of impurities present in sewage may be removed by electrophoresis. Similarly, smoke precipitation. Smoke is also a colloidal system which mainly consists of charged particles of carbon depressed in air. So removal of the dispersed colloidal particles from the air will solve the problem. For this again, process of electrophoresis is again employed. Now, as I was telling you in the beginning itself, like we will be doing a comparative study of the different types of mixtures, solutions, colloids and suspensions. So very quickly then you can compare the particle size. I have already given you a little bit of information regarding the particle size of the three forms of mixture right in the beginning of this session. Still you can have a closer look. So this is the particle size, and this is the basic definition. Solution: homogeneous mixture when two or more substances are dissolved together. Colloids: a colloid contain particles that are in between in size. They do not separate into layers. Fog is a colloid. A property of a colloid is the scattering of light. And suspension is a heterogeneous mixture that separates over time. It lacks stability. Now this is a very important property regarding colloids that I would like to mention at this point, that they cannot be separated from the mixture by the process of filtration, but a specific technique of separation known as centrifugation is employed for it, and they do not settle down when left undisturbed. That is, colloid is quite stable. So let's quickly get into the basic differences. Depending upon the property, how we can figure out the difference. So size of particles is less than 1 nanometer for true solution. Size of particles is between 1 nanometer and 100 nanometer for colloids. For suspension, size of particles is greater than 100 nanometer. Filterability. Pass through ordinary filter paper and also through animal membrane. Colloids pass through ordinary filter paper but not through animal membrane. Suspension do not pass through filter paper or animal membrane. Stability, that is settling down. Particles do not settle down on keeping in solution. In colloids, particles do not settle down on their own but can be made to settle down by centrifugation. Like this is the method employed for separation of butter from milk or cream from milk. Suspension, particles settle down on their own under gravity. Visibility, particles are invisible to the naked eye as well as under a microscope in a true solution. Particles are invisible to the naked eye, but their scattering effect can be observed with the help of a microscope in colloids. Particles are visible to the naked eye in suspension. Separation. The solute and solvent cannot be separated by ordinary filtration or by ultrafiltration for a solution. The solute and solvent cannot be separated by ordinary filtration but can be separated by ultrafiltration in colloids, and the solute and solvent can be separated by ordinary filtration only in suspension. Lastly, about diffusion. Particles diffuse quickly in a solution. Particles diffuse slowly in colloids and do not diffuse in a suspension. So let's quickly recapitulate whatever we have learnt about colloids. A mixture in which the particles never settle. See, even after some time the particles remain in the same state, even if it is left undisturbed. Now, I will like to zoom this picture a little bit so that you can get a clear idea regarding whatever topics we have tried to cover up during this entire session. So everything has been included or rather encapsulated in this picture. So we studied about the different types of colloids, the name of the colloidal system, and I discussed the examples that you can see on the top of this picture. I told you briefly about the different types of colloids, lyophobic and lyophilic, about which you will be studying in your senior classes. I also discussed roughly about the particle size, and obviously in the bottom you will get to know about the method of preparation of colloids and its properties. A little bit of information regarding the properties we have discussed. We had a brief overview. We don't need to get into the detailed analysis of colloids because that is beyond the scope of the syllabus for class 9. But still, I would like to suggest that you should have a nice understanding regarding the topics. Whenever you are being introduced to a new topic, you should go through it and collect as much information as far as possible. So this was all regarding today's session. Thank you.